In part 1, we are to count the number of times we step at 0 on a 0 to 99 marked knob. When we turn left or right, a number of markings as instructed. The input is one turn directive per line. Each directive is a single capital letter L for left or R for right, immediately followed by the number of markings to turn. I map the first characters to plus or minus 1 using a ternary expression, then parse the remaining substring into an integer using C++ string to int. Right from the start, I approach this as a modular arithmetic problem, stepping plus or minus, then wrapping the result into the 0 to 99 range using the modulus operation. Since C++ modulus operator is actually a signed reminder operation, I implemented a true mathematical modulus function to correctly handle the 0 to 99 range. Then, for part 1, I could simply count the number of times we ended up on the 0 marking, while we went through the turn directions. In part 2, I was, for longer than I liked, stumped by the problem formulation. I failed to map it to some simple mathematical modulus operation. But watching some YouTube videos after I solved it calmed me down. The ones I watched encountered the same bewilderment and confusion. It seems this was in fact a nice twist on the part 1 puzzle. I ended up solving it kind of brute force, with each corner case taken care of in an if-else chain of statements. I transformed my solution to track both current and next positions, where next is the unwrapped value before applying modulus to the knob range. In this way, I did not obfuscate the actual distance traveled, which in turn enabled me to look at the next position to see how many times we would pass the 0 position on the knob. The way I did this was to check whether the next position is above 0, at 0, or below 0. If we end up above 0, the number of times we pass 0 equals the number of complete 100 mark intervals we travel. In C++, we get this by integer division on integer arguments. If we end up at 0, this also counts as one click. If we end up below 0, we pass 0 at least once, since we start in the 0 to 99 range, plus once for each additional 100 mark interval. However, there is a corner case. If we started at 0, we need to subtract 1 to avoid double counting the previous landing. While this solution works correctly for all inputs, I'm still curious whether there's a more elegant mathematical approach using just the distance traveled. Let me know in the comments if you have ideas. Warm thanks for watching, and see you in the next one.